us at home, this is Mr. Kazim once again from MOTORSTOLIC International School, Cairo, Egypt. Mathematics teacher for Senior 2. Today we are going to discuss about analytical geometry, that is coordinate. So number one, the linear equation, that is equation on a straight line. When we say linear equation, it means something on a straight line. That is what we mean by linear equation, equation on a straight line. It says these are in form of y is equal to mx plus c. M and c are number, whereby m is the gradient of the line and c is the intercept at y-axis. That is where the graph crosses the y-axis. Example here says the equation of the line passes through the point 2 and 4. As you can see from the graph here. So according to our Cartesian plane, we all know we take our quadrant from the left hand side, that is anti-clockwise. According to our Cartesian, I'm going to rub this place off so that you can be able to, I can make some demonstration. Okay, let me make it here in our Cartesian plane. In our Cartesian plane, here where we have y-axis, we have x-axis, y plus, x minus, then y minus. So the quadrant starts from here anti-clockwise like this. So now, if you look at here, our value for x, we will discover x is positive here. So the value for x will come first, and the one for y will follow. X is positive here, then we have here positive, and our y also is what? Is positive at the same time. We have plus plus.
I don't see it. Let me snap.
Snap.
Did you? Huh?
Snap and let me. So let me make it. I'm going to rub this place up. Good. Now, as I was saying, according to Cartesian, we have something like this. This is Cartesian plane. Then we take our moment comes like this. Here we have y plus, we have x plus, we have x minus, and we have y minus. So then our value for x here is positive. We have positive. And our value for y here also is what? Is positive. We have positive. This is first quadrant. Let me just short it like this. First quadrant. So the next one, we move on to here. Our value for y x here is negative. That is minus. And our value for y here is what? Is positive. We have plus, which is second quadrant. So the next one, our value for x here is negative, and our value for y here is what? Negative as well. So this is third quadrant. And the last one, our value for x here is positive, and our value for y here is negative, which is the fourth quadrant. So now, according to the question that was given, that is, the equation of the line passes through the point 2 and 3. If you are to locate these 2 points here, these 2 will stand for x-axis and these 4 will stand for y-axis, but under what quadrant? If you look at here, the 2 here is positive and the 4 here is positive as well. So in our first quadrant, that is where we have plus and plus. So this relies under what? The first quadrant. So that is that one. So this one says equation of a line with gradient m and a point lies on it. Assume the line L with gradient m and passes through the point A, that is x1 and y1, comma, take any point B, that is x and y, on the line L. So what are they telling us here? According to what is being written here. So we have x plus, we have y plus, we have x minus, we have y minus. So the expression with the gradient m. Yes. And a point lies on it. Assume the L is the L line with gradient m. That is, let's call this one L. We assume we call this one L. So then, passes through the point A. Let's say this is point A. Let's say this is point A. It meets at, this is point A. We have x1, y1. Take any point B, that is x and y, on the line L. That is, we take another point, which is B, on this x and y. So now we have 2 points now. So we have 2 points now. This is what we have been saying. So now, to find our gradient here, which is m, that is, we trace this point here up to here. This is point A. This is x1, y1. So the gradient, trace this one down to whatever the value that we've been given here, and we trace this value up and meet here. So we form something like this, which is called gradient or slope. And it's equal to gradient or slope, which can be represented as m is equal to change in y over change in x, or increase in y over increase in x. So now, if you look from this graph that we drawn on the board, you can call this one x1 and this is y1. So this one will stand for x2 and this one will stand for y2. So now, gradient n is equal to, we have change in y over change in x. So now, the y2, that is this y, will be y minus y1 over x minus x1. This is the gradient, or we call it slope. This is the formula for it. And there is another formula that says, okay, you have to bear this in mind. I'm going to rub this place up. You have to master these formulas, and there's another formula that says y is equal to, from this formula actually, from, okay, let me say from n is equal to y minus y1 over x minus x1. So I can get my value for y here. That is, if I make this y the subject of the formula, so definitely I can multiply both sides here by x1, x minus x1, and multiply here as well x minus x1. X minus x1 we cancel one another, so then we have m into bracket x minus x1 here is equal to y minus y1. So we have made our y subject of the formula there, which is equal to y1, y minus y1, and m into bracket x minus x1. This is another formula, we have to take note of it. And there's another formula that says m1 times m2 is equal to minus 1. You bear this in mind as well. And then you have the last formula that says y is equal to mx plus c. These are the formula we are going to use in solving this equation on a straight line. So let me give you a brief example on how we are going to use the formula. So let me take a little time. Okay. So let's quickly solve a simple example. Find the equation of the line with gradient 2/5 and passes through the point 1 and 4. So now, in this question, it asks us to find the equation of the line with gradient 2/5 and passes through the point 1 and -4. If you can see here, they have already given us the gradient, which is n. We have our n, which is 2/5. They asked us to derive equation for this question. And here we have 1 to be x1 and this is y1. So we take one of this formula here. This is a very suitable formula to use, which is y minus y1 is equal to m into brackets x minus x1. So say y minus our y1 is -4 m into bracket x minus our x1 is -1. So then we place our value for the gradient, which is 2/5. 2/5. Then we move on, say y plus 4 by multiplying this -4 by with the minus here, we have plus. Everything we have plus 4. Here is equal to 2/5 into bracket x minus 1. So then we need to remove this 5 here by multiplying both sides by 5. We multiply here by 5 and we multiply here also by 5. So this 5 cancel this 5 here. So then we have 5 we multiply, we have 5y, 5 times 4 here plus 20 is equal to, we have 2 here. To open this bracket, 2 times x will give us 2x, then 2 times 1 will give us -2. So we move on until we get to the final equation. So then let me repeat this here. 5y plus 20 is equal to 2x minus 2. Then we collect like time. That is, we have x here, we have 2x, we have -2, and we have y here. So x will surely come first. This x will come inside. When plus 2x come inside, it will be -2x. Bring this come inside -2x. Y will follow plus y. 5y, then plus 20, which is this 20. Then you bring this 2 in, then -2, you bring it in to become plus 2. Everything equal to what? Is 0. So then, now we have this -2x plus 5y plus 20 plus 2, then we have 22. Everything equal to what? Is 0. So this is our equation that we are asked to derive. So we are going to stop here for today. In the next class, we will continue. So thank you very much. See you in the next class.